Today's video will discuss chapter 6.2, substitution. So I want you to think of these two equations as equations of a line, which is exactly what they are. And so this is an equation of one line, and this is an equation of another line, and what we're looking for is what value of x and y will make both this statement and this statement true. Okay? And in other words, once we figure that out, what we will figure out is what point does this line share with this line. So the question is, how are we going to solve it? Okay, and so this is called systems of equations. What we're doing is solving these equations simultaneously. However, you don't know how to solve for two variables at the same time. So what we have to do is substitute so that we only have one variable. And so what I'm going to do is if y equals 2x plus 1, I'm going to take this, which we're calling y, and I'm going to substitute it in here for y. So this becomes 3x plus, and now I'm saying y is 2x plus 1 equals negative 9. So in other words, what I'm saying is 3x plus y equals 1, right? And so this is my y. Now I'm going to solve this, which is going to be 5x, or I guess I'm going to simplify this. 5x plus 1 equals negative 9. I'm then going to subtract 1 from both sides. Right? This goes away. I've got 5x equals negative 10. And then I'm going to divide both sides by 5. And x equals negative 2. So I now know what x is. But my problem is that I now need to figure out what is y. So, knowing x, I can now take this x, I can substitute it in here for x, and so I'm going to get y equals 2 times, I'm saying this is negative 2 plus 1. So I'm running out of space. Let me rewrite this where I got some more space. Sorry about that. So I'm going to write it down here. I got y equals 2 times negative 2 plus 1. So this is my y equals 2x plus 1. And I know that x is negative 2. So then I'm going to say y equals negative 4 plus 1, which means that y equals negative 3. Okay? I know my answer now, which means I need to write this in the form of a point on a graph because it's x comma y. So my answer to this is negative 2 because that's my x, comma negative 3. I want you to notice that it is not in fancy parentheses because it's not a set of numbers. It is in regular parentheses because it is a point on the graph. And if I put a negative 2 in here, I will get negative 3. And if I put a negative 2 in here and a negative 3 in here, this statement will also be true. Which means x is negative 2 and y is negative 3 is the only point that will work and make both of these true. Okay, so again, this is just a point on the graph. And if you were to graph these two lines, you would see this is where they intersect. All right, let's take a look at another type of problem. So, in this particular problem, I'm not able to substitute just yet because both of these, if you remember, are in standard form. ax plus by equals c, ax plus by equals c. Just remember the b here is negative. So what I want to do is take this equation, I want to rewrite it so that it's x equals 6 minus 2y, right? I'm going to subtract 2y from both sides. And if I do that, then I can substitute this in for x. So this becomes 3 times 6 minus 2y, because that's x, right? 3 times x, minus 4y equals 28. Have to distribute. This becomes 18 minus 6y minus 4y equals 28. I'm going to simplify. Let's switch colors now. I'm going to simplify. So this is not negative 2y. This is 18 minus 10y equals 28. I then want to subtract 18 from both sides. This goes away. I'm left with negative 10y. Make sure that's negative. 10y equals positive 10. I'm going to divide by negative 10. Sorry, it's a 10. And this is positive y equals negative 1. So I now know y is negative 1. And now I'm going to take that y, and you can substitute it in for either one of these two equations. It probably is easier in this particular example to substitute it in there. But you could substitute it there if you wanted to. So this becomes x plus 2 times negative 1 equals 6. X, 2 times negative 1 is minus 2 equals 6. I'm going to add 2 to both sides. This goes away, and I'm left with x equals 8. Okay, now you can't leave your answer with these two circled numbers, because remember, it's not an x. Oh, almost dropped it. It's a good catch, though, right? So you can't leave your answer like this. What you need to do is this is a point on a graph, which means that it is x, comma, y. And that is my final answer. So these two lines, because this is an equation of a line, and this is an equation of a line, and these two lines share that point. All right, now let's take a look at one last example. And this is kind of when things get a little different. So I'm going to take this y, I'm going to substitute it down here, and I'm going to go kind of quick through this part to get you to what I think is interesting, hoping you find it interesting as well. Right, so it's negative 6x plus 3, and I'm calling this is my y. So negative 6x plus 3y equals negative 12. This is negative 6x plus 6x minus 12 equals negative 12. Some of you see what the problem is going to be. If you don't, we're going to simplify this. Negative 6x plus 6x is 0, so that goes away. So I'm left with negative 12 equals negative 12. Okay? The bad news is that the x is gone. The good news is that negative 12 does in fact equal negative 12. So when you get to a point with this where one of the variables has gone away, you are going to get one of two solutions. In this particular example, it is an infinite number of solutions. Okay, and the reason why there are infinite solutions is because it doesn't matter what x and y I substitute. This statement and this statement, whatever x I choose and y I choose up here, let's say it's 1 and 1, will make this statement true and this statement true. If I choose 1/2 and negative 12, and I put 1/2 here and negative 12 there, then this statement will also be true. Okay, they are in fact actually the same line. That's what infinite solution means. If, okay, and I'm going to pretend for a second that I had done some math and I ended up with something like 8 equals negative 5, right? So this statement, the x is gone and this statement is not true. This is when you get the empty set. Okay? So this is the same line because they share an infinite number of points. This is the empty set because they don't share a single point. So think about what you know about a line that shares every point, right? Two lines that share every point are basically the same line, right? Two lines that never share a point. I mean, that's probably not the greatest drawing of what I'm trying to illustrate, right? So two lines that never share a point that looks something like that, those are parallel. So if you get something where the numbers are the same, you get infinite number of solutions, all that means is that these two equations are the same line. If you get an empty set where the numbers are not the same, it means they don't share any points. It means that, I mean, you can write the empty set, but keep in mind that means that these two lines are in fact parallel lines. All right, so that's all we got for you on substitution. Please make sure that you work on the problems on the bottom of the page. Thanks for watching the video, and I'll see you in class.